Hi folks, my name is Manish Gupta, and in this video I'm going to talk about MADLAD 400 dataset, which is a very large multilingual dataset. So let's see what is this MADLAD 400 dataset. In fact, the dataset has two parts. One is a monolingual part and the other is a bilingual thing for machine translation. Let's look at the monolingual dataset first. So to create this MATLAB 400 monolingual dataset, they started with multiple CommonCrawl snapshots. So they took all the CommonCrawl snapshots. Then they used a language identification model, a massive multilingual language identification model to provide document level annotations. So this finally leads them to a data set, which is a 5 trillion token data set. They call it as a noisy data set because they clean it up further later. Okay. So the way they clean it up is by doing manual annotations and a little bit of a manual quality check. Of course, they don't annotate everything, but they look at languages that they can understand, scripts that they can understand, and so on. They conduct a quality review and then they design appropriate filters to remove noisy content, leading finally to a 3 trillion token clean data set. Okay, so that's a large data set containing 419 languages. So, nicely called out, identified 419 languages on a document corpus containing 3 trillion tokens. Okay. So the kind of cleanups they do are mentioned here. They remove sentences if the language identification for the sentence is not the same as the language identification for the document, right? They also remove sentences which look like lists. That is basically more than 50% tokens begin with a capital letter. They also remove sentences which are too short, less than 20 characters, or too long, greater than 500 characters. They remove sentences where more than 20% characters match with non-alphabetic kind of things. And then they also essentially remove sentences with cursed regexes, like adult or offensive terms and phrases and so on. Yeah. Finally, they remove those documents which have less than 5 sentences. They also do other kinds of cleanup which are language specific and some of them language family specific. For example, Indian languages have this concept of viram or halant, right? So where, if you have some words, for example, tumhare, the ma is half, and therefore, that's basically written with a full ma character along with a viram, right? Now, what happens in many of these languages, and it's not just about Indian languages, it's also about other languages like Khmer and so on, right? So what happens in these languages is that oftentimes on Unicode encoded documents, there's an extra space that comes before that Unicode character, before the Unicode character for the viram or the halant, right? So that is why they do this viram or filtering and correction. They remove all those extraneous spaces before these viram characters. Overall, these 419 languages, they are split as follows. 149 of them are from Asia, and basically, the split is what you see there. Yeah. This is the split of across languages for tokens with respect to what is noisy and what is clean. So essentially, as you see, of course, the noisy data set is larger than the clean data set, which is indicated by the green plus red here. Notice that this scale is logarithmic. So although it may look like that they hardly did any cleanup, a whole large part of this has been cleaned up in that senses. Right? The green color basically shows languages supported on Google Translate, but then there are other tail languages also that they have cared for, in this overall set of 419 languages. Okay, so that's basically the monolingual data. Now, MADLAD 400 also has a bilingual parallel data set. So let's see how this is curated. Well, this has been curated by gathering or by sort of combining data set across multiple machine translation repositories, right? So these are the various data sets that have been included as part of the MADLAD 400 parallel data set. It sort of covers it covers actually 156 languages across 4.1 billion sentence pairs and more than 4,000 language pairs. They removed sentences with more than 75% overlap between source and target. Now, when you're doing machine translation, of course, you expect that the source and target should be different. So remove those sentences which have more than 75% word overlap. Of course, they applied that on sentences with more than 5 tokens, so as to avoid unnecessarily removing things which contain entity names. Now, of course, the entity names, source and target, if the script is shared, then the names would remain the same. So therefore, they applied this heuristic only on sentences with more than 5 tokens. They also removed sentence pairs whose source length to target length ratio falls outside of 0.66 and 1.5. Now, typical fertility of words across pairs of languages lies in that range. So therefore, they removed sentences across, with the ratios differing from that range. They learned, various kinds of machine translation models. So three of them are encoder, decoder, transformer encoder, decoder kind of models: a 3 billion parameter model, a 7.2 billion parameter model, and a 10.7 billion parameter model. They use sentence-based vocabulary with 256K tokens, and the vocabulary is shared across languages between the encoder and decoder side as well. They basically train the data set, train these models on both the data sets, both the monolingual data set and the parallel data set. On monolingual data set, they essentially use a mass model style objective. So to pre-train this model, and for the bilingual data set, for this parallel data set, of course, they use the machine translation objective. So the training is done, the pre-training is done in a monolingual and a bilingual way together, with every batch containing about 50% instances from the bilingual objective and 50% instances from the monolingual objective. So also they have several languages. So the way they sample their languages is using the recently popular Unimax sampling strategy to sample languages such that up to 10 epochs, up to 10 epochs are considered for any particular language. They also train another model. So besides these three encoder decoder models, they also train an 8 billion decoder only model, and they trained only on the monolingual data. So the 8 billion decoder only model is not trained on the machine translation data, but only on the monolingual data using UL2 objective, and they show results using both zero shot and few shot on machine translation for this 8 billion decoder model also. Okay. So how do these machine translation models perform? So MADLAD data is great, but if you train these models, how do they perform? So in the paper, they show results on 5 different data sets. Here I've just shown on 2 of them. So you see there are 3 encoder decoder models are being compared here. You also see that their 8 billion decoder only model is compared with the zero shot as well as few shot kind of settings. You also see here the no language left behind, the popular model from Meta being compared. So this MATLAB data comes from LNAI and LLB is from Meta, right? So, and you see the comparisons from other languages to English and English to other languages, as typically done in machine translation literature, right? So you also see that there are 2 metrics being reported, BLUE and CHRF, and this table is on a data set called as WMT. This table is on a data set called as Flores 200, right? So what you observe here, and of course on Flores 200, they also report XX to YY, meaning any language to any other language except that in X source or target is not English. Okay. So what do you see here? You basically see that the 7.2 billion and this 10.7 billion models are competitive with significantly larger NLLB model. So this NLLB model is actually 54 billion parameter model, although it's not mentioned here. So if you think about it, this thing, if you see these numbers are very competitive compared to these numbers. Again, if you look at, say, 58.5, that's not too worse compared to 59.2. Similarly, 31.8 is very similar to 32.7, which is sort of lower, but then, also notice that these models are 5x smaller, right? So that's important. And this model is hugely smaller, right? About 8x smaller, 7x smaller at least, 7 to 8x smaller, right? So that's that. Now, on Flores 200, also you see similar story. Yes, the proposed models are not very, they're not better than the NLLB model, but they are much smaller models and still are reasonably accurate. They are within, sort of a particular range compared to the NLLB model. Now, of course, NLLB model is for the riches. So essentially, if you do not have so much of GPU RAM, and you might as well try out using these empty models. So that's it for this video. And just to summarize, we discussed MADLAD 400, which is a highly multilingual general web domain document level text data set across 419 languages. It's sort of cleaned to a good extent, right? So using MADLAD 400, these guys trained large machine translation models, both transformer encoder decoder models and also a decoder only model. Their models seem to be performing comparably with the much larger NLP machine translation models. And if you want to sort of experiment with them, they are openly available. the clean data set, the noisy data set, and also the models that we talked about. Okay, so hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.